Look up at the night sky. Now tell me, if there are literally trillions of stars out there, burning hotter and brighter than anything you've ever seen on Earth, now why is the sky black? Think about it for a second. If you're standing inside a forest, no matter which direction you look, you see a tree. The trees are everywhere. Now imagine those trees are stars. In every single direction you look in space, there should be a star. Billions of galaxies, trillions upon trillions of stars. The math says the entire sky should be absolutely blazing with light. Every inch of it glowing like the surface of the sun. Every single inch. But it's not. You step outside at night, and you're met with darkness. Cold, silent, almost unsettling darkness. So what's going on? Why isn't the sky on fire with light? This question, as simple as it sounds, broke the minds of some of the greatest scientists in history. And the answer, when you finally get to it, will make you see the universe in a way you never have before. This mystery has a name. Scientists call it Olbers' paradox. In 1823, a German astronomer named Heinrich Wilhelm Olbers looked at the night sky and asked the exact same question you just did. He wasn't the first person to notice it. Even Edgar Allan Poe, the horror writer, wrote about this mystery. But Olbers framed it so precisely, so sharply, that it became one of the most talked about puzzles in all of science. And for decades, literally decades, nobody had a satisfying answer. To really feel the weight of this paradox, you need to understand the scale of what we're dealing with. Because when most people hear billions of stars, their brain nods politely and moves on. It doesn't actually process what that means. So let's fix that. Our galaxy alone, the Milky Way, contains somewhere between 100 billion and 400 billion stars. That's just our one galaxy, just ours. Now, the observable universe, the part of space we can actually see, contains an estimated 2 trillion galaxies. 2 trillion. That number came from a 2016 study using data from the Hubble Space Telescope. And it shook the scientific community because the old estimate was around 200 billion galaxies. They were off by a factor of 10. The universe is 10 times more crowded with galaxies than we thought. Each of those galaxies has anywhere from millions to trillions of stars inside them. So when you do the math, and I won't make you do the math, the number of stars in the observable universe is so enormous that standard number notation barely handles it. We're talking about something like a 10 followed by 24 zeros. That is not a number. That is a psychological event. And all of those stars are pumping out light, constantly, right now, as you sit here watching this. So the question hits even harder now, doesn't it? Why is it dark? Here's where it gets beautiful. The answer isn't one thing. It's a combination of truths about the universe that, when they stack together, create that darkness you see every night. And each one of these truths is more mind-bending than the last. The first truth is this: the universe has an age. It is not infinitely old. It did not always exist. Roughly 8 billion years ago, yes, we know the number pretty precisely, thanks to measurements of something called the cosmic microwave background, the universe began. The Big Bang. Before that point, time itself didn't exist in any form we understand. There was no before. This is genuinely hard for the human brain to process because we're wired to always ask, but what was before that? And in this case, the answer is that the question doesn't apply. There is no before. Time started. The universe started. That's it. Now here's why this matters for our dark sky. Light travels fast, about 300,000 kilometers per second. Nothing in the universe moves faster. But fast doesn't mean instant. Light still takes time to travel. The light from the sun takes about 8 minutes to reach your eyes. The light from the next nearest star system, Proxima Centauri, takes over 4 years. The light from the center of our own galaxy takes around 26,000 years. And light from distant galaxies? It can take billions of years to reach us. So here's the thing. If the universe is only 8 billion years old, then only the light from stars that are close enough within 8 billion light years has had time to reach us. Any star that exists beyond that distance, its light is still traveling toward us. It hasn't arrived yet. We are literally waiting for it. We're sitting in a universe that's surrounded by a wall of unreached light, and we're just not old enough yet to see it. Think of it like this. Imagine you're in a completely dark room, and someone starts lighting candles at the far end. The light from the nearest candles reaches you almost instantly, but the ones at the very back of the room, you won't see those for a few seconds. Now stretch that analogy to cosmic scales. The room is 93 billion light years across, the estimated size of the observable universe, and the few seconds becomes billions of years. We are that person standing in the room, and the candles at the back haven't lit up our corner yet. But wait, you might be thinking, okay, but even within those 8 billion light years, there are still trillions of stars. Shouldn't their combined light still be enough to light up the whole sky? And this is where the second truth comes in. And this one is honestly one of the most dramatic discoveries in all of human history. The universe is expanding, not just the stuff inside it, not just galaxies drifting apart like debris after an explosion, but space itself is stretching. The fabric of the universe is getting bigger. Edwin Hubble discovered this in the late 1920s, when he noticed that almost every galaxy we could see was moving away from us. And the farther away the galaxy, the faster it was receding. This was the first hard evidence that the universe wasn't static. It was growing. Now here's what expansion does to light. When a source of light is moving away from you, its waves get stretched. The technical word is redshift. Think about an ambulance siren. As it drives away from you, the sound waves stretch out and the pitch drops. Light works the same way. When a galaxy is speeding away from us, the light waves from its stars get stretched. Stretched light shifts toward the red end of the spectrum. Stretch it further and it shifts past red into infrared, invisible to your eyes. Stretch it even more and it becomes microwave radiation. Still there, still real, but completely invisible to human vision. And here's the brutal part. The galaxies at the edge of what we can observe aren't just moving away quickly. Some of them are receding at speeds that effectively mean their light, even though it started traveling toward us billions of years ago, arrives here so stretched out that it's no longer visible light at all. It's been downgraded. The universe has taken their light and quietly converted it into something we can't see. It's not that the light disappeared. It's that it arrived in a form human eyes were never built to detect. So imagine this. All those billions of galaxies, all those trillions of stars, a significant portion of their light is reaching us right now, but it's invisible. It's washing over us in the form of infrared radiation and microwaves, and we have no idea it's there unless we use special instruments. The darkness isn't emptiness, it's invisibility. There's actually a third piece to this puzzle, and it's a bit darker in tone. Stars don't live forever. Our sun, for example, has been burning for about 6 billion years and has roughly another 5 billion years left. But in the full context of the universe, even a 10 billion year lifespan is not infinite. Stars are born from clouds of gas and dust. They burn through their fuel. They die, sometimes quietly, sometimes in spectacular explosions called supernovae. After a star dies, it doesn't keep producing light. It becomes a white dwarf, a neutron star, or in the most extreme cases, a black hole. Objects that give off little to no visible light. So as you look out into space, many of the points in the sky that would theoretically contribute to that wall of light, their sources no longer exist. The star that should have lit up that tiny patch of sky ran out of fuel a billion years ago. The light that was supposed to fill that spot has nowhere to come from anymore. But here is where this whole story becomes almost poetic. Remember we said the universe is expanding, that space itself is stretching? That expansion also means that as you go further and further back in time, the universe was smaller, more compressed, hotter. Before that moment, it was so hot and dense that light couldn't even travel. It would be immediately absorbed and re-emitted. It was like trying to look through a glowing fog. That first flash of light, that moment when the universe finally let photons travel freely, is still detectable today. We call it the cosmic microwave background radiation, or CMB. It was discovered accidentally in 1965 by two Bell Labs scientists, Arno Penzias and Robert Wilson, who kept getting a strange, inexplicable noise in their radio antenna. They thought it was pigeon droppings interfering with the equipment. No, seriously, they actually cleaned the antenna. The noise remained. It turned out to be the oldest light in the universe, stretched so much by billions of years of cosmic expansion that it now exists as microwave radiation, invisible to our eyes but detectable by sensitive instruments. They won the Nobel Prize in Physics for it in 1978. That signal, that ancient glow, is essentially the echo of the universe's first breath. And it's everywhere. It fills the entire sky. Every direction you point a sensitive radio telescope, there it is. The universe has a background hum, a fossil of light from before galaxies, before stars, before anything we would recognize. That hum is part of the answer to why the visible night sky is dark. The oldest light has been stretched far beyond what we can see. Now pull back and hold all of this together at once. The night sky is dark because the universe is too young for all the light to have reached us. Because the universe is expanding and stretching that light into invisibility. Because stars have lifespans and many that should be contributing light are already dead. And because the oldest light of all has been so thoroughly stretched that it now belongs to a frequency range our eyes can't access. The darkness isn't absence. It's an illusion. The sky is absolutely filled with light. Most of it just doesn't speak the language our eyes understand. We're surrounded by invisible radiation from dead stars, dying galaxies, and the very first moment the universe became transparent. The darkness you see when you look up is actually one of the most information-rich environments in all of existence. It just requires the right instruments and the right questions to read it. And here's the thing that should really stay with you. Everything we just talked about, the expansion of the universe, the finite age of the universe, the redshifting of light, all of it was unknown when Olbers posed his paradox in 1823. He was working with an older model of the universe, one that was assumed to be infinite, eternal, and static. No one knew it had a beginning. No one knew it was expanding. And yet the question he asked, this kicks this seemingly simple, almost childlike question of why is the sky dark, turned out to be a thread that, when pulled, unraveled some of the deepest truths about reality itself. That's the power of a good question. It doesn't need to sound profound. Why is the sky dark? Sounds like something a 5-year-old asks. But this particular 5-year-old question took humanity almost 150 years to answer properly, required the discovery of the Big Bang Theory, the expansion of the universe, and the detection of the oldest light in existence to fully resolve. And even now, there are layers we're still working through. The cherry on top, the Hubble Space Telescope once conducted an experiment where it pointed at a tiny, seemingly empty, completely dark patch of sky. A patch so small it was like looking at a grain of sand held at arm's length. They pointed it there for nearly 10 consecutive days, collecting every last photon. What came back was one of the most famous images in scientific history, the Hubble Deep Field. That tiny, dark, empty patch of sky was filled with over 3,000 galaxies, each galaxy containing hundreds of billions of stars, in a spot that looked like nothing.